Hello students, welcome back to my channel JPPHYSICS. In last lecture we have discussed about the lower speed limit for the vehicle when it is traveling along a banked curved road. Now in this lecture we are going to derive the expression for higher speed limit, that is upper speed limit, when the vehicle is moving along a banked curved road. What will be the maximum, that is upper speed limit for the vehicle? Let us consider that derivation, that is upper speed limit. For this also we are going to consider a vehicle is moving along a banked road. See, again we will draw one diagram for this. Let this is angle of banking theta. This is inclined road, and on this road this vehicle is moving. Okay. Now, in last case, when we have considered the lower speed limit, what we have considered? The friction is away from the center. Correct? Friction is away from the center. Now, here the frictional force we are going to consider towards the center. This force will be, frictional force will be towards the center. That is friction between the tires and the road will be towards the center. When we are going to find out the upper speed limit, we have to consider the friction towards the center of the road. Okay. Now, again, here we have to draw the FBD. So, this is weight force mg acting in downward direction. This normal force is perpendicular to the inclined road. Here again we are going to consider the components of normal here. Okay, and this is horizontal component. This is vertical component. Again I will draw proper. See, this. If this is theta, correct, this angle will be theta alternate, then this 90 minus theta, and this will be theta. In last lecture we have considered that how this angle will be theta. Okay, so the component which is near to the theta, we are going to consider n cos theta, and which is perpendicular, it is n sin theta. Okay, now here this is one component of Fs. See, here there is a Fs acting towards the center. So there will be two components, that is this component. Now, if this angle is theta, this angle is also theta. Correct? So what will be this component? This component will be Fs cos of theta. This component will be Fs cos of theta. That is adjacent or near to the theta. And this component, downward component, this component will be Fs sin theta. Are you getting this? See, Fs, I will draw it separately. See, here there is Fs, correct? Okay, and this angle is theta, means this angle is also theta, means the component which is near to the theta, to this theta, near to the theta, because this is Fs, correct? So this will be Fs cos theta, and this component, perpendicular component, that will be Fs sin theta. Near to the theta, it will be Fs cos theta. Far from the theta, that will be sin theta. So Fs cos theta, Fs sin theta. Now, if you again observe the diagram, you comes to know that, see, this Fs sin theta and mg balances this n cos theta, correct? See, this Fs sin theta plus this mg, which are in a downward direction, they are balancing this n cos theta. So what I can write? See, mg plus Fs sin theta is equal to what? N cos theta. So I will write mg is equal to n cos theta minus Fs sin theta, equation number 1. Now, see, this n sin theta and this Fs cos theta both are directed towards the center of the circular path, correct? So these two are providing the centripetal force. That is n sine theta plus fs cos theta are providing centripetal force. That is, this is the curved road and this will be the center. Towards the center, which two forces are directed? N sine theta, fs cos theta. Both common providing centripetal force. So what I can write, mv square by r, this is the centripetal force, and this centripetal force is provided by these two components, that is n sine theta plus fs cos of theta. Okay, let this equation number 2. Again divide equation number 2 by 1. mv square by rmg is equal to n sine theta plus fs cos theta divided by n cos theta minus fs sine theta. Okay. Again, what I am going to do, put the value of this fs. What is that? Mu s into n. What will happen? This m will get cancelled. V square upon rg is equal to n sine theta plus mu s into n cos of theta divided by n cos theta minus fs sine theta. Correct? Sorry, here there will be mu s into n again. Now divide numerator and denominator again by n cos theta. Same process. But in case of a lower limit, we have considered the friction away from the center. And in case of a upper limit, we are going to consider the friction force towards the center. And that's why only this minus sign in lower limit, it was in the numerator, and plus sign in the denominator. Here the case will be inverse. Plus sign is in the numerator and minus is in the denominator, and this gives the upper limit. How? Let us see. V square upon Rg is equal to, if I divide this numerator and denominator by n cos theta, here n will get cancelled and only the remaining term will be n sin theta upon cos theta, that is tan theta, plus mu s n cos theta upon n cos theta, means only mu s will be there, n cos theta get cancelled. Now n cos theta upon n cos theta, that will be 1 minus mu s n sin theta upon n cos theta, n will get cancelled and only the remaining term will be mu s tan theta. Mu s tan theta. So what will be V? V will be under root Rg in bracket tan theta plus mu s divided by 1 minus mu s tan of theta. See, in that expression minus was here and plus was here, means denominator was bigger. That is, it was a lower limit. But here plus sign is in the numerator, minus sign is in the denominator, means denominator is lower and resulting value will be more. That is, it is a upper limit. So what is the upper speed limit for the vehicle? It is V is equal to under root Rg in bracket tan theta plus mu s upon 1 minus mu s tan theta. Again, if you put this mu s is equal to 0 here, that is no friction is there. If no friction is there, this mu s will be 0, only tan theta will be here. Mu s tan theta becomes 0, means formula will be V is equal to under root Rg tan theta. That formula we have discussed in last lectures. So this is the expression for upper speed limit, means maximum set speed limit acquired by the vehicle is must be V is equal to under root Rg tan theta plus mu s upon 1 minus mu s tan theta. You understood this derivation? So if you understand this derivation, like my channel, subscribe and share it. Press the bell icon so that you will get the notification about next lecture. And also I have told you already that if you have any doubt regarding the rotational dynamics about that numerical, about theory, whatever may be that, ask me in comment box. I will give the answer for it. Okay. Thank you.